7.5 is solving linear trig equations. So linear equations. So remember, linear equations are just, where the variable is linear. It's to the exponent 1. So when I solve linear equations, I bring over terms and I can solve for the variable. Right? This is solving linear equations, unlike solving quadratic equations where I bring everything over to one side's equal to 0, and then I use factoring or quadratic. So understanding the difference is pretty important between 7.5 and 7.6. So we do the same thing. Linear is really easy. So I got to determine all the solutions for 2 sine x plus 1 equals 0 over this interval. So it's always going to give you an interval because solving trig equations, because they are periodic, there's an infinite number of solutions. So if you don't restrict the interval, you have an infinite number of solutions. Okay, so I write down the equation. I got 2 sine x plus 1 equals 0. And now I just solve like this is an x value. So I bring over the 1. So it's going to be 2 sine x equals negative 1. And then I divide by 2. And I get here. And even if you're in grade 9, you can get to this position right here. And from this position, we should know what to do in grade 12 and in grade 11, although we're in radians, so grade 12. Now I just got to solve for x when sine x is negative 1 over 2. Well, I do the thing that I usually do. I say, well, if it's negative, I know it's here and here, and I got to solve for theta. I never use a negative in here, so if I want to find x, it's going to be sine negative 1 of positive 1 over 2, and I'm going to relate that to the related acute angle. That's an easy special triangle one. So x is pi over 6. Okay, but that's not enough. This is just what my theta equals, or, this is x. After I found out that it's pi over 6 from the special angles or my calculator, I have to say, well, I know one of my answers is pi plus pi over 6, and another one of my answers is 2 pi minus pi over 6. So I have 7 pi over 6 and 11 pi over 6. And these are my solutions. X equals. Okay, and these are both within 0 and 2 pi. I have not exceeded 2 pi. 2 pi is 12 pi over 6. Okay, I could check if there's more solutions by adding a period to each one of these and seeing if it's in the same range. But I also know that there's only 2 solutions because the k value is 1. Okay, so I'm just going to say that every question. If the k value is 1, there's 1 cycle between 0 and 2 pi, which means there's at most 2 answers. If the k value is 2, it means there are 2 cycles between 0 and 2 pi, which means there could be 1, 2, 3, 4 possible answers. So I can look at the k value and I know kind of how many solutions there's going to be between 0 and 2 pi. Okay? Or you could just keep adding a period to each of the answers until you're outside of the range of the question. That's easy too. Okay, done. Next one. I have a tan, so I'm going to bring things over and solve. My first step is going to be divide by 3. So I'm going to say tan theta plus 1 equals 2 over 3. Now I'm going to bring over the 1. So tan theta is 2 over 3 minus 1. Add my fractions. 2 over 3 minus 3 over 3 is negative 1 over 3. And I'm at that position where I have to solve using trig. I make a little chart. Where is tan negative? Well, it's negative slope. So in those 2 quadrants. I need to know when tan is 1 over 3. So I'm going to say theta is second function of tan of 1 over 3. That is not a special triangle, so I can't memorize that one. So I'm going to get my calculator. I'm going to make sure it's in degree mode. Degree mode. Luckily, I'm already in there from my other class. And luckily, I didn't use my calculator for the first one because I was in degree mode. Second function tan of 1 over 3 equals 18.4. So theta is 18 degrees, which is this and this. Okay, again, this is not my answer. I now have to say pi minus and 2 pi minus. So theta equals pi minus, not pi, sorry, 180. 180 minus 18 and theta equals 360 minus 18. Okay, I've already made that mistake twice, assuming that this question was in radians, so be careful. The question range is in degrees, so I have to prove my answers in degrees. 180 minus 18 is 162. 162 degrees is one of my answers. 360 minus 18 is 342. And 342 degrees. And this is my second answer. The K value here is 1, so I know the period is 360, just to reiterate the same thing over and over. If I add 360 to this, I'm definitely out of this range. If I add 360 to this, I'm definitely out of this range. These are my only two answers. Okay, now in word problems, even though we've done this in last chapter, even though we kind of didn't need to, when you come up with a formula for a word problem, because you know how from chapter 6, and you have to solve for when this formula equals a certain value, same question as the tide question in chapter 6. So the tides in Canada, East Coast can be modeled by the equation blah, where D is the depth of the water in meters and T is the time in hours after midnight. If your boat needs a depth of 2 meters to move safely in the water, at what time could you safely use your boat? So I got to figure out when will 4 plus 3.5 cos of pi over 6t equal 2. When will this be true? Okay, so again, if you're solving linear trig equations, I'm just going to bring the numbers over to one side. So this 4 has got to come to the left. This 3.5 needs to be divided. And then I'm going to be stuck somewhere with a k value other than 1 for the first time on this board. So 2 minus 4 is 3.5 cos pi over 6t. That's a negative 2. I'm going to divide at the same time. Equals cos pi over 6t. Change this to a decimal or a fraction. It's negative 4 over 7 equals cos pi over 6t. Now, whenever you have a k value that is different, just do the same thing, but instead of when you're solving, see how this k value is 1? This is like saying my k value is 1, therefore I'm solving for 1x. Well, if my k value is pi over 6t, then I'm solving for pi over 6t. So do the normal thing right here. When is cos negative? Here, here. This is t, this is t. So I'm going to do second function cos of 4 over 7. Remember, I'm not using the negative. The negative has informed me of the location. Get my calculator. Radian mode now. So I got to go change my angle units to radian. And now I'm going to go cos negative 1 of 4 over 7. And that's going to be 0.96. And this equals t. Okay, but it actually doesn't equal t, it equals pi over 6t. So alert, because you're solving for this entire thing, I gotta say pi over 6t equals 0.96. But actually, before I do that, I should come up with the real solutions. It's pi minus 0.96, pi plus 0.96. So those are the two things I'm going to come up with first. So I'm going to say the time is pi minus 0.96, and the time is pi plus 0.96. Get my two answers. I'm going to say pi plus 0.96 is 4.1, and pi, this is 4.1, and pi minus 0.96 is 2.18. Yes, sir.
What happens to pi over 6?
Yeah, I'm going to bring it back right now. Okay, so I could bring back the pi over 6 here and use the pi over 6, but there's not really a need to, because it's just more writing, even though technically, mathematically, it would be correct. So now that I actually solve for t, like every other question, now I bring back the pi over 6. So now I'm going to say, well, the solutions are actually pi over 6t is 2.18, and pi over 6t is 4.1. And now I have to solve for t. So I multiply by 6, 2.18 times 6 divided by pi. Get my calculator. 2.18 times 6 equals, divided by pi equals 4.16. Okay, and I'm going to go 4.1 times 6 divided by pi equals 7.8. Okay, so these are the times that the equation is equal to 2. Now I got to change those into time. So 4 is going to be 4 a.m. and 16 is going to be 16% of 60 minutes. That's how I find it. So I just do 0.16 times 60, 0.16 times 60, and I get 9. So this is at 4:09. The next one I'm going to do 0.8 times 60, because I need 7 a.m. and 80% of the way to 8 a.m. And that's 48 minutes. So this is 7:48 a.m. Okay, now, these are the times where I'm restricted in my exit, right? So I can't exit between 4 and 7, whatever the case may be. Now, a question came up where, there's a lot of boxes here. What are my answers? I always box like key points. And to be honest, usually when I get to a further step, I'll like underline it or something to find my way. But I don't, when questions get really busy and lengthy, I just box key points. So when I have to go back, I only have to look here. Like, I don't care about this. This is like a math that I did and I'm happy with. But I want to look at this. I'm like, did I bring those numbers here correctly? Those are important aspects. Okay, now, to find other answers, I need to know what the period is. So I get my calculator. My k value is pi over 6. So I go 2 pi divided by pi over 6. And I get 12. The period in this question is 12. So I can add 12 to any one of my answers to get other answers. So this could be, 16:09 or 4:09 p.m. and 7:48 p.m. So these are actually all 4 answers. Now I know you're thinking, this doesn't really tell us when I can exit. Okay, it does not tell us when we can exit. But I could just plug in a point between these times, like 5, into my equation. So I'm going to say 4 plus 3.5 cos of pi over 6 times 5. I'm using the time 5. And my calculator is dripping. There. And I get 0.96. That's below 2. So if it's below 2 between these times, then I know outside of these times, I can move my boat. So it's actually not from 4.409 to 7:48. Therefore, I can move between 7:48 a.m. and 4:09 p.m. Okay, so again, I tested 5, which is 5 a.m., and I cannot move my boat, which means between these times, no good. But on the outside of these times, we're good. So not 4:09 to 7, 7 to 4:09, and I just changed the a.m. and the p.m. If you don't feel safe, you can plug in a point between these times, 12, 10, and it should be greater than 2. Okay, last one. This is where identities come back. Identities make a comeback. I cannot solve a trig equation when I have multiple trig functions. I cannot do it. I have to have one trig function. It's like solving for x and y. Well, you got to replace y for a version of x, and then you can solve. So when I have multiple trig functions, I generally have to use an identity to replace the trig function. Now I can replace this with a version of sine, but that's not really going to get rid of this cos. So I'm going to replace this with sine of 2 theta, my double angle formula. And now I can divide by cos 2 theta, which gives me a 1 on the right side. And this can convert into tan 2 theta. Now, I don't have to replace this with the double angle formula for tan 2 theta. You shouldn't be thinking in that direction when you're solving equations. I have to solve for when tan is 1. And then I'm going to set that equal to 2 theta. And then I'm going to do the same thing that I usually do. So I'm going to say, well, 2 theta equals tan negative 1. See, actually, I'm doing the 2 theta over here, but I didn't do the pi over 6 over here. In hindsight, I probably should have. I just don't like doing it when I have to still find the answers. So we're going to get back to that question for sure. Tan negative 1 of 1. When is tan positive? Here. When is it 1? At pi over 4. And pi plus pi over 4. Okay, special triangles. So I know that 2 theta is pi over 4, and 2 theta is 5 pi over 4. And now I'm going to solve. I got to divide by 2, so theta is pi over 8, and theta is 5 pi over 8. And these are 2 solutions. But this guy right here tells me I have double the amount of solutions between 0 and 2 pi. This was a 3, I got triple the amount of solutions, 6 solutions. If this was tan 4 theta, you have 8 solutions between 0 and 2 pi. Okay, it's just, you're going to figure that out as you do some questions. I got to find more solutions. Or you can think, well, if I add a period, am I going to still be within the range? Let's see. The period here is pi. 2 pi divided by 2 is pi. Okay, remember the formula for the period when you have an equation is 2 pi over k. So if my k value is 2, the 2's cancel out and my period is pi. So I can add pi to both of these. I'm going to go here. Theta equals pi over 8 plus pi, which is going to be 9 pi over 8. Well, that's less than 16 pi over 8, which is a 2 pi. And I'm going to do 5 pi over 8 plus pi is going to be 13 pi over 8. That's less than 16 pi over 8. That's a solution. You want to keep going. If I go one more and I add another 8 to this numerator, which is another full pi, I'm going to be at 17 pi over 8. This is another solution, but it is outside the range of 2 pi because it's 17 pi over 8. 16 pi over 8 is my upper limit. So this is not a solution. So I got 1, 2, 3, 4 solutions. You shouldn't really make a mistake leaving out solutions because if you just always try to add a period to all of your solutions and you keep doing it until you're out of the range, you're right. It's an easy way to understand it. I know it's kind of messy because I didn't have much space on this board, but that is solving linear trig equations.